All right, welcome to this edition of Stats Chats. Here we're talking about the difference between clinical significance and statistical significance. It's important to note that clinical significance is sometimes also called practical significance. And clinical significance is defined by the American Psychological Association as the degree to which a research study has demonstrated results that are meaningful with regard to a diagnosis or treatment of a disorder. And one example of a clinically significant finding may be an outcome demonstrating a psychological intervention like self-compassion, meditation is effective in reducing symptoms of anxiety. Statistical significance, on the other hand, is often used when we conduct a statistical test and we calculate the p-value. The acceptable p-value in the social sciences is typically 5% or less. So when the outcome of a null hypothesis test, remember the null hypothesis suggests there's no difference in the findings, but when the outcome of the test is that we can reject the null hypothesis, then we conclude that there is a statistically significant difference. This means we have evidence to support the alternative hypothesis, which indicates that there is a statistically significant difference. And it's likely, 95% likely, that it's not due to chance, but rather, in the case of our example, due to self-compassion, meditation, or the intervention that we're examining. In other words, a successful outcome can be attributed to the intervention or the independent variable. An example of statistical significance is demonstrated in this quote from Knight and colleagues' 2021 article on creatively increasing empathy. It says, descriptive statistics were used to assess the baseline empathy scores as measured by the interpersonal reactivity index, and paired sample t-tests were utilized to examine changes in empathy as measured by the interpersonal reactivity index. Regarding empathy subscales, the participants reported statistically significant improvement in perspective taking, with the t-value equaling 2.26 and a p-value of 0.027. So we see the statistically significant finding indicates that the researchers rejected their null hypothesis and concluded that their empathy training did lead to an increase in empathy scores from pre-test to post-test. So another consideration is a finding may be clinically significant if we notice a reduction in symptoms or some form of meaningful clinical change. However, that doesn't necessarily mean it's statistically significant. The change may not be different enough. So let's say we look at the pre-test mean or average and the post-test mean or average, and we see there's been a change or a difference, but it may not be enough for the difference to be statistically significant at the 0.05 level. Remember, at the 0.05 alpha level, we're taking a risk of being wrong about rejecting our null 5% of the time, but we're 95% certain that the results are not due to chance at that 0.05 level. So if we didn't find statistically significant results at the 0.05 level, this may be due to measurement error, maybe due to a low sample size, maybe we didn't have a control group. For example, in some cases, like severe treatment of depression, when there's a suicide risk, we would not want to withhold treatment. And so in those cases, perhaps we wouldn't have a control group, which might impact the findings. So even if there's no statistical significance, there may be practical significance or clinical significance in some cases. So it just depends on what the study involves. Sometimes an effect is not statistically significant, but we recognize its meaningful change did happen. So the participants experienced some sort of benefit, but the statistical change may not have showed up as a function of low sample size, measurement, or some other issue with the study. But clinically, we can see positive change. We're just not necessarily seeing it statistically significant. And note, these two are not mutually exclusive. Effect size is another term that's important to be familiar with. And effect size is something that can at least tell the reader, the researcher, and give us an idea of the magnitude of the change of the intervention. So if I'm looking at the effect size, I can at least see what the intervention is doing, positive or negative. And so this matches up with my clinical or practical significance. So some people might think of the practitioner when it comes to clinical significance and meaningful change clinically versus the researcher who's often looking for statistical significance. significance. But it's important to note that these roles are not mutually exclusive, but they can just help you differentiate the different types of significance. Effect size is an important term to keep in mind when we're evaluating significance. It helps us know the magnitude of the change that's taken place and helps us to understand what does the intervention do. One example of effect size is Cohen's d, which measures the magnitude of change in terms of the units or number of standard deviations between two means. And it's often been called a measure of practical significance, whereas the p-value is a measure of statistical significance. Statistical significance is often seen as a dichotomous choice. Either we reject the null hypothesis or we fail to reject the null hypothesis. There's no partial significance or p plus or p minus. It's just that the value is less than or equal to 0.05 or it's greater than 0.05. And if it's less than or equal to 0.05, it's less than 0.05, we reject the null hypothesis. But with Cohen's d and effect size, this is not a dichotomous decision. There's a continuum. If there's a value for Cohen's d that's close to 0 or near 0, we would say there's no effect. If it's around 0.2, we'd say that's a small effect. 0.5 represents a medium effect, and 0.8 and above represents a large effect. The number needed to treat is also a helpful value to keep in mind, and this is a type of effect size and often represents the it's similar to what we would do with like a power analysis using a power calculator like G power, but it would helps us understand for a member of the treatment group to benefit over the control group, how many people would we need to treat. Now, some researchers like Jacobson and colleagues have defined clinical significance in 1984 to include two rigid guidelines. And one is that a specific transition from a dysfunctional sample, so like a DSM-5 diagnosis where a specific disorder is interfering with functioning, to a functional sample where that specific disorder is no longer interfering with functioning. And number two, for that improvement to exceed what would be expected by measurement error alone. And that is calculated by the reliable change index, which is measured by the post-test score minus the pre-test score divided by the standard error of measurement. Now, it's important to note that the standard error of measurement is different from the standard error of the mean. You may see them both abbreviated with SEM, but the standard error of the mean looks at the square root of x1 minus m squared plus x2 minus m squared plus x3 minus m squared, and so on, all divided by n. The standard error of measurement estimates a variation around the true score for an individual when repeated measures are taken. So again, this is more about measurement error rather than looking at the standard error of the mean. So the standard error of measurement is calculated as the standard deviation times the square root of 1 minus r, where r is the reliability coefficient of a test. That value is calculated and used in the denominator of the reliable change index. And this formula, according to Jacobson and colleagues, if the reliable change index is equal to or greater than 1.96, one would expect that a change of magnitude to occur by chance approximately 5 times in 100. And then we would say that the improvement exceeds what would be expected by measurement error. And in that case, Jacobson and colleagues would say that the requirements are met for clinical significance. So when it comes to clinical significance, you could use the APA definition where we're talking about, going back to that slide, we're talking about a meaningful change with regard to a diagnosis or treatment of a disorder. Or you could use the Jacobson and colleagues' more stringent criteria, which suggests that we move from dysfunction to function, and then also that the amount of change exceeds what would be expected due to measurement error. So in summary, when we consider all these things, it may be helpful to think about how you define meaningful change and be able to make a case that meaningful change has occurred if you believe your findings are clinically significant. There is some value in the reliable change index as it takes into account measurement error. Clinically significant results are, in the case of Jacobson and colleagues' definition, much more stringent. If we hold ourselves to those suggested standards, and they may be appropriate in cases where the stakes are very high, such as in life or death situations, medication dosages, or pharmaceutical studies. Statistical significance is certainly a good starting point. It may help us know when an intervention is responsible for an effect rather than chance, and that intervention may merit further study, but it's certainly not the end of the discussion. It may just be a starting point for that discussion. I hope that this gives you some concepts to contemplate as you continue your research. Thanks for watching. God bless you.